Hello students, so today we will do one of the very important topics of physics, dimensional analysis. We have learnt earlier that any physical quantities can be written as a product of fundamental quantities. Product means division is also included. So any physical quantity can be written as product of fundamental quantities. This is very important. So the index or exponent of that fundamental quantity that is coming into the expression is called dimensions of that quantity in that fundamental quantity. This would be clear by a simple example. Velocity. You know, velocity is distance upon time. So I can say velocity is distance upon, so I can say velocity is equal to distance into time upon time. I can say t raised to minus 1. So this is velocity. So if this is the velocity, now distance is measured in length. Time is measured in t, we say, isn't it? So its fundamental quantity would be L into t raised to minus 1. If there is no index in L, I can write 1. So my velocity is L raised to 1, t raised to minus 1. Now this exponent or index are called dimensions of that quantity. So I will say velocity has dimension 1 for L and dimension minus 1 for t. So I would say in this manner, dimensions of velocity is 1 in length and minus 1 in time. So in this manner, we find the dimensions of any physical quantity. Okay, so normally these dimensions are written in square brackets like I have written here. So I would say L raised to 1, t raised to minus 1 square bracket. This is dimensional formula of velocity. So this is called dimensional formula of velocity. Now listen carefully. If I say v square, so mean dimension of v is equal to this. So this is called dimensions equation of velocity. So this is dimension equation of velocity and this is dimensional formula of velocity. So any physical quantity we should write as a product of fundamental quantities and then write their symbols. Okay. Normally, you know there are 7, but these 3 are most fundamental: m, mass, length and time. So in case any quantity is not there, we write its index to be 0. So velocity I can write as m raised to 0, L raised to 1, t raised to minus 1 in square bracket. So this is dimensional formula of velocity. Because there is no mass, so we should so for fundamental quantity at least you should write m, l and t with index. If there is no that thing, you write it raised to 0. Is it alright? Now let us go to second example. Density. You know density is mass upon volume. So mass, and what is unit of velocity? It is 3 lengths, pi r square h, or length into breadth into height. Volume will have 3 dimensions. So it can be written as m multiplied by L raised to minus 3. So this is the product of density in terms of mass and length because there is no time involved here. So how will I dimensional formula of density? Square bracket m raised to 1, L raised to minus 3, t raised to 0. So this is the dimensional formula of density. Now similarly, now let us write dimensional formula of force. Force is mass into acceleration. So mass I will write as mass, but acceleration I can write change of velocity upon time. So mass I will write as mass. Now change of velocity means length upon time and upon time. So the denominator will be 2 times. So my formula will become mass into length into time square. So it will become m raised to 1, L raised to minus 1, t raised to minus 2. These are dimensions of force. So this is very important because force comes into our dimensional analysis quite often. So we start with force. So force you should learn m1, m raised to 1, l raised to 1, t raised to minus 2 are dimensions of force. So here what I will say, force has dimensions 1 in mass, 1 in length and minus 2 in time. And if somebody says write dimensional equation, so I will say left hand side and right hand side both. Force in square bracket is equal to m1 l1 t raised to minus 2. Is it all right? So then we will do, now I will explain to the procedure, and then we will do we'll find the dimensions of physical quantities. So what? So from the examples that we have solved so far, so now we can write the procedure that you should use the definition of physical quantity, like I have used the definition force is mass into acceleration. Then you write dimensions, you write physical quantities in terms of fundamental quantities. Write physical in terms of fundamental quantities or quantities whose dimensions are known. Like suppose I know the dimension of acceleration, then I can say force is equal to mass into acceleration. So m, so I can say dimensions of force are mass into acceleration. Acceleration I know, L t raised to minus 2. So mass into acceleration. So this is the dimensions of force. So I can write in terms of fundamental quantities or quantities dimensions are known. Then you substitute the fundamental quantities and you will get the answer. So that's what I written step 2. And finally we get physical quantities only in terms of product of fundamental quantities, and dimensions can be written. Now this thing would be clear by few examples that I am doing now. We want to find dimensional formula for kinetic energy. Kinetic energy means E is equal to half mv square. So half constants have no fundamental quantities, so m will come, and then v square. V I know is L upon 2, L upon t, bracket is to 2. So now expand this, so we got m L square t raised to minus 2. So this is dimensions of energy or kinetic energy. So in this manner you write the first step, write the definition, E is equal to half mv square. Then you substitute the fundamental, write in terms of fundamental quantities or whose dimensions we know. So like I written in terms of V, I know the dimension of V is L upon T. I can write the answer. Now next example, this we have done now. Work is force into displacement. You know dimensions of force. So thus displacement is L. So force is m1 L1 t raised to minus 2 multiplied by L. Mass into force into displacement. So now so multiply this two, so L will increase by 1, the rest will remain same. So m1 L square t raised to minus 2. So this is the procedure. Is it all right? Next, universal constant of gravitation G. We know F is equal to, first step, definition of physical quantity. So F is equal to G m1 m2 r square. I want G, so I will write G is equal to F r square into m1 m2. Now I know dimensions of F. I know dimensions of r square going to be L square. Denominator is m into m, so m raised to minus 2. So I will say dimensions of G are, I am writing the equation, force L square m raised to minus 2. Substitute the dimensions of force and multiply this, you will get the answer. Is it all right? Next, electric charge. So again, first definition, current is rate of flow of charge. I is Q upon T. This is the definition. So Q is equal to IT. Now I know is A ampere A. Time is T. So A raised to 1, T raised to 1, but I will write M0 L0 also. Is it all right? So in this manner, dimensions have to be written. Now few more examples. Strain, this we will be learning in physics later on. Change in length upon length. So both are length. So they will cancel. So M0, L0, T0. So we say strain is dimensionless. It does not have any dimension. Then specific heat. This is very important. Specific heat. This I learned in your 10th standard. Q is equal to MC into change in temperature. Q is MC. So I want for C. So C is Q upon MT. Now what is Q? It is energy. So I know the dimension of energy. So I will write the dimension of energy divided by M and divided by T. That's what I have written. These are the dimensions of energy which we have derived. M1 L square T raised to minus 2. This is M raised to minus 1 and this temperature is K raised to minus 1. So I get the answer. Okay. Then we will go to universal gas constant. We know the first, always write the formula. PV is equal to nRT. I want to write R. So we write R is equal to something. And now we should write dimension of each physical quantity. P, pressure. What is pressure? Force upon area. Force I know. Area is L square. So I will get dimension of pressure. M L raised to minus 1, T raised to minus 2. Force divided by L square. Then V, volume is L cube. Quite simple. N is number of moles. So mole raised to minus 1. T is temperature. So K raised to minus because it's in denominator. So this is what was in the denominator. This is V. This is P. You simplify, you will get this answer. So this is how we find the dimensions. Okay. Now, let us go to slightly difficult physical quantity. Young's modulus, we will be studying about this, is Y. It is defined as longitudinal stress upon longitudinal strain. Strain we have done is delta L upon L, so both will get cancelled, nothing. Longitudinal stress is force per unit area. So force you know divided by L square, you get the answer. Then coefficient of viscosity. So definition is force upon area into velocity gradient. Force is ml T raised to minus 2. Area is L square. Now velocity gradient means, see, this is viscosity. So means things is flowing. Here velocity is more. Here velocity is very less where it is sticking to the pipe. A velocity is changing. Okay. So velocity is changing along the width of this. So it is velocity upon distance. So velocity you know. Velocity is L T raised to minus 1. Then we have to divide by distance. So again divide by L. So it will become T raised to minus 1. So we know this, so we get the answer. Now surface tension is simple. Force upon length. We will be learning about surface tension in second term. So force you know, divide by L. Planck's constant. This also will be learning. Is energy upon frequency. So frequency means 1 upon T. You know, if body is vibrating or something, then the period, reciprocal of period is the frequency, means how many times it is doing per second. So frequency is 1 upon T. This you might be knowing, you have done it 10th. Then energy, you know, frequency is 1 upon T, you get the answer. Potential V, this is very important. By definition of potential, V is work upon charge. By definition of potential is work upon charge. Right for work, right charge is, we have done today, it is A into T, ampere into time, rate of flow of charge, rate of flow of current. Charge is rate of flow of current, so A into T. So we get the answer. Resistance is V upon I. The study in 10th standard, resistance is V upon I. V we have derived now. I is current, means it is A. So look at the answer. So in this manner, in case you know physics and the definitions of the physical quantities, you can derive the dimensions. Next. Now these are important type of sum. It says taking velocity, time and force. So V, time is T, force is F. Now it says let us take these three as fundamental quantities. We take normally fundamental quantities mass, length and time. So it says if V, T and F are fundamental, then what would be dimensions of mass? So first write the definition. For force he has given, the force is m into A, or mass would be F into A. Now force is fundamental, so F will remain. What is acceleration? Velocity per unit time. Change over V t raised to minus 1. So we get the answer. Now this is in general, many times you can do it in this manner. Now here it says we have to find the dimension of force and impulse, and velocity, density and frequency are base. So this is my basic. Velocity is V, density is rho, frequency I have written nu. Okay. So these are my basic. Now I want to write in force number. So what I will do, first I will write this thing. Velocity is density and frequency. So frequency, this is very simple. Frequency is 1 upon period. So frequency is 1 upon period. Density is mass per unit length. So density is mass per unit length. And velocity is distance traveled per unit length. So this is my velocity. So my velocity in terms of fundamental is this, density is this, nu is this. Nu is frequency. Now, so we have got three equations. So let us make now and get the value of m, l and t in terms of these fundamental quantities. Once we know m, l and t, then we know dimensions of all quantities, so we will substitute, we will get in terms of this. So like nu, so this is very simple. Nu is t raised to minus 1. So t would be nu raised to minus 1. So I got the one answer. Q is nu raised to minus 1. So this is my new fundamental and this is my old t. Then I will find L, because L is V upon t. T raised to minus 1 will come, bring it here, so L would be V and t raised to minus 1 it will become t raised to plus 1. So V is my fundamental and t I know the value, nu raised to minus 1, so I will get the value of L. V into nu raised to minus 1. Now M I will get from here. M is density upon density into L raised to 3. Here it will become positive. Value of L I know, I have just calculated, and density is fundamental, so I get the value of M also. Now I know all the three: time, length and mass in front of fundamental. Now force, you know, ml t raised to minus 2. Substitute the value of ml and t, you will get the answer. Similarly, impulse is force multiplied by time. So force we know in terms of new fundamental also, and time also I know in terms of new fundamental. Time is nu raised to minus 1. So substitute the value, we will get the answer. So in this manner, this type of sums sometimes comes in the exam. Okay, so today I have explained to you dimensional, how to find dimensions of physical quantities. Is it all right? So revise this topic and come for the come in the next session after revising this, so that it will be easy for you to understand. Thank you.